This is a video for AQA Further Pure Mathematics, Algebra and Graphs section 1.1, where we're looking at the idea of asymptotes of rational functions. Well, firstly then, let's consider what we actually mean by a rational function. So a rational function is one where we have f of x is equal to p of x over q of x, where p and q are polynomials. Now, a polynomial, remember, is just an expression with powers of x, so x to the power 0, x to the power 1, x to the power 2, etc. What we must have, of course, though, is that q of x, the denominator, cannot be equal to 0, because if q of x is equal to 0, then the function f of x will not be defined at all. Well, a simple example of a rational function that you'll be very familiar with is f of x equals 1 over x. We need to think about the graph of 1 over x and what properties it has. Well, we know first of all that x cannot be equal to 0, because then we have 1 over 0, so we have a function which is not then defined. But we can think about what happens when x gets close to this value. So as x gets closer and closer to 0, then the y value gets closer and closer to infinity. So it gets larger and larger, either positive or negative. So on the graph, that would be indicated by the line climbing higher and higher as it approaches the y-axis, or lower and lower as it approaches from the other side. As x gets larger, either positive or negative, then y approaches 0. Now we will consider this sort of idea of how we sketch graphs in later videos. It's quite difficult for me to draw on this screen, but the graph looks something like that. But importantly, it has what we call asymptotes. So the y-axis is what's referred to as a vertical asymptote, coming down here, and the x-axis is a horizontal asymptote. So an asymptote is a line that the graph approaches but doesn't actually reach, so an asymptote. So here we have a rather better diagram showing 1 over x than I can sketch on the tablet here. So we said that a vertical asymptote occurs where the function gets larger and larger without bound. So this is going to happen when the denominator approaches 0. So there's our vertical asymptote. And then the horizontal asymptote is where it's approaching a constant value, not necessarily 0, or in this case it is 0. So this is what happens when the x value gets larger and larger. Now in general then a linear, what's called a linear rational function, is where the polynomials p of x and q of x are both linear functions. In other words, they have a power x1, x to the power 1, rather than x squared or x cubed. And here we can see then that the numerator, ax plus b, if that's equal to 0, then the function f of x will be equal to 0, as long as the denominator is not also 0. And this gives us a value for the x-intercept. So is there a value which makes the function itself equal to 0. If we look at the denominator, then we have that c of x plus d is equal to 0. Then we have f of x is undefined. So as an example of that, we could consider this function. We've got 2x minus 1 for the numerator and x minus 1 for the denominator. And we can see that when x approaches, then we're going to have the f of x approaching infinity. And it has a vertical asymptote at x is equal to 1. And when x approaches infinity, or negative infinity, we can see that f of x will approach 2x over x. In other words, the negative 1 in the top line and the bottom line are irrelevant. So it's going to get closer and closer to 2x over x, or in other words, it's going to get closer and closer to 2. Therefore, we've got a horizontal asymptote at 2. In summary then, for a graph, the thought that we've been looking at, then the vertical asymptote occurs where the denominator q of x is equal to 0, and a horizontal will occur when we've got the x is approaching plus or minus infinity, and then the b and d in the expressions will become irrelevant, so we end up with a over c as being our horizontal asymptote. That's the end of this introduction to sketching graphs. In the next video we will be sketching more complex rational functions where p of x and q of x are of higher order, and we'll also consider the linear one that we looked at earlier. We didn't actually sketch its graph, but we will do so in the next video.